All right, guys. Hey, I'm Abhishek from Router Protocol, and I have Shivam with me. So Shivam will be demoing the use case of how to build cross-chain NFTs using Router Protocol. Before that, I'll just give a quick context of what Router Protocol is and what is the problem that we are trying to solve here, right? So yeah, at Router Protocol, what we are building is an infrastructure layer which will enable the cross-chain ecosystem. Now, now, if you think about it today, right, there are multiple chains which are available where you can build your dApps and you can deploy your dApps at. But one of the problem which remains is that the user is fragmented, right? So let's say there are users who are using Polygon, and then there are certain users who are on Ethereum, right? Every user has a different choice, and every user has a different need from that particular blockchain. Now the problem for the dApp remains is that if they build a dApp on Ethereum, then they are not able to get the users who are on Polygon, and similarly, the users who are on Ethereum, they are not able to access the dApps on Polygon unless they go to that network and they try to switch their network and everything, right? So what we are trying to build at Router Protocol is we are enabling this whole cross-chain ecosystem, which will enable your users from any chain to be able to access any dApp on any chain, right? And this is a very, very powerful thing. So according to us, what we believe is that there will be multiple chains which will exist in the future as well, but there should be a way to communicate across these chains so that users are able to access each and every element of different chains which are being deployed on those chains. So moving on, at Router we have multiple products. So we are trying to solve for two major problems, right? So one of the problems is moving assets across chain. So if you think about it, again, you have USDT on Ethereum, you would want to do something on Polygon, so you would want to move those funds to Polygon, right? So one of the things that we solve at Router is providing asset transfer from one chain to another, which is what our cross-chain token transfer is. We have three sub-products within it, a router widget, a router pathfinder API, and a JS SDK using which you can enable this functionality for your own dApp. And then second is cross-chain instruction/messages, and we provide this via Router CrossTalk. We'll go into Router CrossTalk in a bit more detail on the next slide. All right, great. So what is Router CrossTalk, right? And what do we mean by cross-chain instruction or cross-chain messages? So let's say you have a contract on Polygon. Now, if you have to access that contract or execute any function on that contract on Polygon, what you need to do is you need to switch your network to Polygon and then be able to access that particular function on that contract. But let's say if you were on BSC and you would want to execute that function on Polygon, you would not be able to do that by sitting on BSC chain, right? So CrossTalk enables you to do that particular thing. I'll give you a more relatable example. So let's say you have funds on BSC chain. You have, let's say, 1000 USDC on BSC. And you realize that there is a really great farming opportunity on Polygon, right? Where you are able to get a really great APR. Now, to be able to farm that opportunity, what you would need to do is you would need to first transfer your funds from Polygon to BSC, transfer those $1,000. And then at the same time, you should also have the BNB native token, because if you have to stake your funds on BNB chain, you would need BNB native token. And then finally, you would be able to stake it on that particular farm, right? So if you think about it from a user point of view, there are three steps involved. One, transfer of USDT token. Second, acquisition of the native token on that chain. And third, you have to go and stake finally on that particular chain. Now think about this. For a user, it's very cumbersome and it takes a lot of time. And also, he is at the risk whether his funds have reached the chain or not. He's always thinking about those aspects. With Router Protocol, you will be able to do this in one single step. So the user will be on BSC chain and he will be able to stake something on Polygon in a single click without having to change his network, without having to think about how to acquire the native tokens of that particular chain. And just in a single click, he will be able to access whatever functionalities the BSC chain is providing by sitting on Polygon itself. So this is something which is very powerful according to us, and we feel that in the future as well, cross-chain is the ecosystem which will keep on building. Yeah, so on CrossTalk, right, we provide two major things. One is just the instruction transfer. What I mean by just instruction transfer is that if you want to just execute a particular function by, let's say you are sitting on Polygon and you want to execute a particular function on BSC, that's what a simple instruction transfer means. And second, there could be a need for transferring tokens first and then executing a particular function. For example, like we were discussing the staking example, where you would want to first transfer the funds and then stake those funds on that particular chain. So that is something which is a sequencing kind of a problem where you need to first execute the transfer of funds and then execute the staking. So that is also provided by Router CrossTalk. So we have two major functionalities, just the generic transfer as well as staking as along with instruction transfer along with the token transfers. Yeah, moving on. So today what we'll be showcasing is cross-chain NFTs. Now, before we go into what how we are going to build cross-chain NFTs, let's think about why do we need a cross-chain NFT. We have heard about a lot of metaverses, we have heard about a lot of P2E games coming up in the future, and we have heard about a lot of these games being deployed on multiple networks. If you take an example of Sandbox, Sandbox is not just deployed on Ethereum, but it is also deployed on Polygon, right? And similarly, there are a lot of other protocols which are coming up in line, right? For example, StepN, right? Which was walk to earn. They are deployed on 3 different networks, but on the 3 different networks, they work in their own single zone, right? So essentially, a user who is on Polygon, they need to have the NFT on Polygon, and then they'll be able to access StepN functionalities or let's say a Sandbox functionalities. And similarly, a user who is on Ethereum, he will have to have the Ethereum NFT to be able to access the Ethereum functionality of the particular Sandbox or StepN, right? So this leads to fragmentation for that particular dApp as well. But what if, let's say, these NFTs are cross-chain transferable? So a user who is on Polygon does not necessarily need to remain on Polygon. He could transfer this NFT from Polygon to Ethereum and then work along with the Ethereum people and kind of utilize whatever features are provided on the Ethereum network. And similarly, a user who is on Ethereum could move to Polygon and reduce the gas cost that he has to give and utilize the capabilities on Polygon itself. So NFT transfers in this way will enable metaverses to go cross-chain much more easily without having to have fragmented users across different chains. So how do we do this? So what we have is, this is the architecture that we have. So essentially think about it, if you think about it, there is a NFT which is sitting on chain A. What we do is, we burn this NFT on chain A, and then using router crosstalk, we transfer a message that we have burned this NFT for user A. So mint this NFT for user A on chain B, right? So router crosstalk will take the message from chain A and then on chain B, it will execute a function where it will mint this NFT to the user who is sitting on, for the user with the address which was provided on chain B. So hence you are able to move the NFT from chain A to chain B without having to, acquire NFTs on both the chains, rather having one NFT and being able to access features across both the chains, which is possible. So there are multiple use cases for cross-chain NFTs. So one of them we discussed right now, but there are other use cases as well. So for example, there is a new NFT token which is coming up on, let's say, Ethereum, and you have funds on Polygon. Today, what you have to do is, if you have to mint that token on Ethereum, you have to first transfer your funds from Polygon to Ethereum, and then mint that token on Ethereum. Now, if you were to integrate router crosstalk, what you could potentially do is, you could just on a single click from Ethereum itself, mint the token on Ethereum. In a single click from Polygon itself, having the funds on Polygon, you could just mint the token on Ethereum. So in a single click, you are able to do all the transactions rather than having to do multiple steps and then being able to mint the token. So now Shivam will showcase, how to build this using router crosstalk and also demo how you can actually move the NFT from one chain to another.
Hello, yeah. So, hello guys, I'm Shivam, and I'm a member of developer team at Router. Today I'll be showcasing you how you can build cross-chain NFTs using router crosstalk. So, let's go to the code editor. It's not changing.
Can you share the whole screen? It's only sharing the application. Can you share the whole screen? Yeah, right.
Okay. Okay. So here you can see this is the contract that we are going to build. So what we actually are doing is we are taking the standard ERC 1155 contract from OpenZeppelin, and we are just integrating router crosstalk with it. So an additional functionality that is to transfer cross-chain will be added to it. I'll show you how you can integrate router crosstalk in this NFT. So here we have an owner address, and there is a cross-chain gas limit, which I'll be talking about later. So in the constructor, you are passing the URI. So this URI is for NFT, for any general NFT you want to create a contract. But here is a generic handler address. So this is the handler that will handle your cross-chain requests. Whenever you create a cross-chain request, it will go to the handler and it will handle it. And where can you find the addresses to the handler? So you can go to dev.routerprotocol.com. And here you can see, yeah. So here inside the deployment addresses, you can find all the generic handler addresses for testnets as well as mainnets. Okay. So you can initialize router crosstalk here using the generic handler address. Now, I have created the general mint function just for testing. So in a mainnet environment, you would want to have some fee tokens also, but it's just for testing. So this has nothing to do with crosstalk. Now, there are these three functions which are mandatory admin functions that need to be created to integrate crosstalk. So these three functions you just need to copy and paste into your contract. I'll walk you through what each of these mean. So first is the set linker contract. So if you want to take your NFTs to multiple chains, you would want your contract on chain Polygon to know its counterparts on other chains also. So if you have deployed your contracts on Polygon, BSC, and Phantom, you would want your Polygon contract to know that my counterpart on BSC and Phantom is this and this address, right? And similarly for the other two. So linker is that admin address that has the capability to map the contracts across chains. Then the second is set fee token. So router takes some fee for providing the bridging services because we have to do some transactions for that. So we provide multiple fee token support. So you can check out all the fee tokens here. So yeah, supported fee tokens for crosstalk. You can check out what all fee tokens we provide. You can add any of these tokens as fee token and we'll be taking fees in that token only. Also, you are not going to pay the fees directly. You have to provide those fee tokens to your contract. So your contract will be paying the generic handler for that fees. And for that thing, you have to approve the fees from your contract to the generic handler so that generic handler can cut the fees from the contract itself, right? So for that purpose, we have the approve fees function. Then there is a cross-chain gas limit. What does this mean? So we provide the flexibility to the developer that they can tell us that this is the amount of gas limit I want when you are executing the transaction on destination chain. So you have created the function, you know what amount of gas limit it is going to incur, right? So you can set the cross-chain gas limit and we'll take that amount and while executing on the destination chain, we'll use that amount as the gas limit. Then okay, yeah. So from this function, what we can do is we can create a cross-chain request. So what is happening here is, what are we accepting? First is the chain ID. So this is the chain ID of the destination chain, and this is not the actual chain ID, but the router-defined chain ID. So we at router have created some chain IDs for different chains. So I'll show that also. So in the supported chains parameter, you can see for Ethereum, we have the internal chain ID 7 as well as for other chains we have listed here. So you will need to pass that chain ID here as the destination chain ID. So if you are going from Polygon to BSC, and for BSC we accept the chain ID 2, so you will need to pass 2 here. Second is the recipient address. So this is the address of the user on the destination chain that is going to receive the NFT. Third is the IDs and amounts. So these are the IDs of NFTs you want to transfer and the respective amounts that you want to transfer. Then there is the data. So this is the data that the arbitrary data you give when you are going to mint ERC1155 tokens. If you do not have any data, you can pass 0x00. Then this is the cross-chain gas price. So as we discussed about cross-chain gas limit, we also provide you the flexibility to determine what amount of cross-chain gas price you are going to provide. And on the basis of this gas limit and gas price only, we'll be charging you the fees. But if you pass a lower gas price than required on the destination chain, your transaction may get stuck on the bridge, and we also have a replay functionality for that. So you'll be getting a hash here, the bytes 32 returned here. You can use that bytes 32 hash to replay your transaction again. Now, how we are creating a cross-chain request. So we are sending all this data to the send cross-chain function, and it is first burning your NFTs. So in the architecture, we saw that we'll burn your NFTs on the source chain, right? So we'll be burning your NFTs here. Then we'll create a selector to the function that we want to call on the destination chain. So this receive cross-chain function exists on this contract itself, and it will be deployed on multiple chains. So this is the function that will be called on the destination chain when the cross-chain request is received, right? So you can see there is a function of this name, right? So we'll be discussing about it later. So here we create a selector to that function, and then we create a data. So what is this data? This is the data that you want to pass to that function. So this is the address of recipient, this is the token IDs, this is the respective amounts, and this is the data for minting, right? So that arbitrary data. And we'll just pass all these parameters to the router send function, which will create a cross-chain request. And it will return you a hash, which can later be used to replay your transaction if your transaction gets stuck on the bridge due to lower gas limit or gas price you passed. Okay. Now there is this router sync handler function. It's an internal function. So this is the function that will be called on the destination chain by our bridge. So you have to handle all your cross-chain requests inside this function only. So here we know we only have one cross-chain request. We are creating only one cross-chain request. That is why we do not need to check if this is the request for this function or that. But otherwise, you can always create a selector to that function and match the selectors and then decode the data accordingly. So we knew that we will be going to receive the recipient address, IDs, amounts, and data inside the data field. So we decode it accordingly. And then we call that function for which the selector was passed here. And we pass all these data to that selector. So let's go to that selector first. So the selector was for receive cross-chain function. And what this does is, it just mints you the amount. So we already knew that the NFTs were burnt on the source chain, and we are just minting it here on the destination chain. You can see it's an external function, but for security purposes, that is why we have added a isSelf modifier so that only this contract itself can call this function. So whatever handlers you have that you are going to call inside the router sync handler function, you will have to incorporate this isSelf modifier so that no other address, contract, or externally owned wallet is able to call this function except this contract itself. Okay. Now we have the replay transaction function. So suppose you passed gas limit that is lower than what is required on Polygon, which was your destination chain. So what will happen is your transaction will be tried on the bridge, but it will get stuck because of the lower gas price you passed. So that is why we have a replay transaction function. So you can use the hash that you received while you called the transfer cross-chain function. You can pass a new gas limit and gas price, and you can replay the transaction. Now we have, okay, so these functions do not have anything to do with CrossTalk. This is for the ERC 1155. And this is because this was a testing contract. So if anything went wrong, we would want to recover our fee token. So that's why it was created. Now, moving on to deployment part. And if any of you have any doubts in the contract itself, you can ask. Then we'll move on to deployment part. Okay, so let's move on to the deployments part. Okay, yeah. So first you have to create this deployments.json because we have automated the deployment process. So you just need to fill up these details here in the deployments.json just before deploying. So here what we accept is according to the chain ID, you can define the handler address, which you can get on dev.routerprotocol.com. Then the linker address. So this is my address actually because I want to map the contracts on different chains. Then third one is fee token. So the fee token I have kept as the route token because you get almost a 50 to 60% discount on the bridging fees if you use the route token. Then the URI, then the cross-chain gas limit, and after deployment, your address will be stored here. So it is automated. When you deploy, the address will be stored here directly. Oh, sorry. It's not changing. Yeah. Okay. So you can populate all the details here about the handler, linker, fee token, URI, and cross-chain gas. So if you want to create your own contracts, you would want to define the parameters yourself. So Now, moving on to the deployments part. So this is all automated, only one-click deployment is there. So what we have done here is, we have a deploy function, which will take all the details from that deployments file you created. It will put into the ERC1155 deployment contract. So it is passing the URI and the handler, and it gets deployed. Then it is setting the linker address, and setting the fee token address, approving the fee tokens, as well as setting the cross-chain gas. So all the things are being done here. And once you deploy on multiple chains, you will need to map all the chains together, right? So from Polygon, if you deploy on Polygon, Phantom, and BSC, you will need to map from Polygon to Phantom, from Polygon to BSC, and similarly for the other chains, right? So we have actually deployed this contract, and I'll show you, I'll transfer some tokens cross-chain and show you how it is done. So we'll go to we'll use Polygon and Arbitrum. So we'll transfer funds from Polygon to Arbitrum. So here you can see we have some fee tokens already here, the route tokens. And for token ID 1, I have balance of 5 here. And in Arbitrum, for token ID 1, I have balance of 5. Okay. Now I would want to transfer these 5 tokens from Polygon to Arbitrum. Okay. So here the chain ID. Okay. So at dev.routerprotocol.com, you can find that Arbitrum has internal chain ID 5. So I pass 5 here. Then this is the recipient address. So this is my address. You can see. So I pass my address here as recipient address. Then I want to transfer token ID 1, and I want to transfer 5 amounts, so that because I have 5 here, so I want to transfer all of that. And I want to pass some cross-chain gas. So I am passing 1 GUI. Okay, there is some MetaMask error. Let me check. Okay. So the transaction is done from the Polygon side. And in some time, we'll see that we received that NFT here. So it will become 10 once we receive here. Okay, the transaction is complete from this side. You can see we have burned those 5 NFTs here in this transaction, and we have paid some route tokens as fees. Okay, so now if we check here, we have the 10 tokens for the same token ID, right? So it's transferred cross-chain from Polygon to Arbitrum in just 15 to 20 seconds, I think. So that is the power of cross-chain. Thank you. And if you have any questions for me, you can ask, feel free to ask.
I have my own custom transfer as well as burn functions in my own contract. How can I use this? Will I have to rewrite the whole thing, or how will
we
it work?
have some sample contracts for ERC20, ERC721 as well as 1155. So we have some standards, but if you want to have custom contracts, then you have to make some changes. But yeah, most of the functionality will be same, because the admin functions, that set linker, set fees token, will remain there as it is. You will only need to change 2 things. First one is how you are sending a cross-chain request. So here we had a transfer cross-chain function with which we were sending the request. So first you would have to change that. The second one is you will have to handle that request inside the router sync handler. That's it. No more changes required. So it is that easy to integrate router crosstalk. Anyone else has any doubts? Okay guys, thank you.